Let's go to page 41 and start with number 36. It says, in a triangle whose side length are in a ratio of 6 to 8 to 9, is this triangle acute, right, or obtuse? So what you need to do is apply the inequality theorem. So what you do, you square the longest side and you want to compare with the sum of the square of the other two sides. Okay. And so this would be 81, and this would be 36 plus 64. So 81, and this would be less than 100. So if this is less than, this would be acute. Okay. So you can basically, what you do is you square the longest, and now if they are equal, then you're going to have a right triangle. Then if the square of the longest side is bigger, then you're going to have obtuse because the opening is much bigger. Okay. Okay, let's go to number 37. Okay, so from the length of the altitude to the 14-inch side of the triangle, whose two other sides have lengths of 13 and 15. Okay, so the altitude, you're looking for the altitude. So you got one side is 13, the other side is 15. Okay, so this one, what you want to do is you want to, since the three sides are given, you can find the area, and once you find the area, you can go backward to find the height. Okay, so the three sides are given, so you need to go ahead and use the Heron's formula. So S, the semi perimeter equal to 13 plus 14 plus 15 divided by 2. So S equal to 21. And so therefore the area equal to square root of S times S minus A, S minus B, S minus C. So K is the area, so area equal to 21 times, so you just use this minus each one of that. So this minus will give you 6, this minus that will give you 7, this minus will give you 8. And in a competition, most of the time you're not allowed to use calculator. So to simplify this, you need to know how to do it without a calculator. So what you do is break it up into small bits and pieces. Don't multiply into large numbers. So it will give you 3 and 7. This will give you 2 and 3. And this will be a 7. And this will give you 2 and 4. So you want to break into perfect squares. Okay, so this one and this one will give you a 3. This one and this one will give you a 7. This one and this one will give you a 2. And this one will give you a 2. And therefore this will give you 84. So the area of the triangle is equal to 84. And which is also equal to 1/2 base times height, right? So K equal to 1/2 base times height. And so you can substitute, so 84 equal to 1/2, the base is 14, and times the height. Okay, so multiply by 2 to give it a fraction. Divide by 14, so this cancel out. And this can also cancel out, so divide by 7. And so H equal to 12. Okay, let's go to the next one. Okay, in triangle ADC, the angle bisect the DV is drawn. Okay, so let's go and draw. You got so triangle ADC, and the angle bisect the DB is drawn. If AB equal to 3, if AB equal to 3, AD equal to 6. And CD equal to 8, find BD. Okay. Okay, so what we need to do is first we need to apply to find this. Okay, we need to use the angle bisector theorem to find this. Once we find this, we can use Stewart theorem to find that. Okay, so use angle bisector theorem. So let's go and call this y. Okay, so you're going to have the 6 over 3, so this over this equal to 8 over y. Okay, and cross multiply, divide by 6, so y equal to 4. So y equal to 4. Okay, so now we can apply the Stewart theorem. So the way to do it is this times this will be 6 times 8. So this times this equal to this times by itself plus this times that. So this times this equal to this times this plus this times that. Okay. So it's kind of not too difficult to memorize. Okay. So you got 48 equal to x squared plus 12 minus 12 on both sides. And take the square root, so x equal to 6. Okay, let's go to the next one. If the sides of a triangle are in a ratio of 4, 6, 8, then find the cosine of the smallest angle. Okay, so you have 4, 6, 8. And since you're looking for you're using trigonometry, so the actual number doesn't matter. So since it's already 4, 6, 8, let's just go and let a equal to 4. You can even reduce it to 2, 3, 4. Okay, so a equal to 4, b equal to 6, c equal to 8. Okay, and since the a is the shorter length, so angle A would be the smallest angle, right? Because small angle we're facing the short side, the biggest angle we're facing the longer side. Okay, so since the three sides are known and we're looking for the angle, then we can go and use the law of cosine for the angle A. So we're going to have a squared equal to b squared plus c squared minus 2bc cosine of A. So substitute everything here. So you got 4 squared equal to 6 squared plus 8 squared minus 2 times 6 times 8 cosine of A. Okay, so you got 16 equal to 36 plus 64 minus equal to 96 cosine of A. And so this is equal to 100, so minus 100 on both sides. We got negative 84 equal to negative 96 cosine of A. And then you divide by negative 96, divide by negative 96. So cosine of A equal to 7 over 8. Okay. Okay, let's go to the next one. Okay, triangle ABC is such that AB equal to 4, AC equal to 8. Okay, so let's go and draw that. Okay, so you got AB equal to 4 and AC equal to 8, and M is the midpoint, and AM equal to 3. And what's the length of BC? Okay. Okay. So to do this kind of problem, what we need to do is we need to extend these and make into a parallelogram. Okay, so if this, since we're making the parallelogram, if this is 3, this would be a 3, this is 4, this would be a 4, this would be 8, this would be an 8. Okay, and this would be congruent. Okay? Okay. So what we need to do is we need to use one of the theorem that have to do with the diagonals. Okay. So what is that? That theorem says that if you okay, the theorem is that the diagonal, the sum of the square of a diagonal equal to sum of the square of the all four sides. So what it's saying is that the BC square, so this square, okay, that's going to call this D, plus AD square, so this square plus this square will equal to square the sum of the square of each side, equal to AC square plus CD square plus BD square plus AB square. So again, this diagonal square plus this diagonal square will equal to the square of the sum of the square of each side. So it would be the square of this plus square of this plus square of this plus square of that. Right. So now that's going to substitute whatever we know. So BC square plus AD square, so it would be 36 equal to AC square, CD square, BD square, AB square. So BC square plus 36 will equal to, okay, this is 80, so 80 plus 80 is 160, minus 36. So BC square equal to 124. So BC equal to square root of 124. And to simplify, you can just go off to the side. So BC equal to 2 square root of 31. Okay, let's go to the next one. Number 41. It says use the law of sines to prove the angle bisector theorem. Okay, ledger A, B, C, D. Okay, so first I use the law of sine for triangle ACD. So this triangle over here. So AC over angle ADC is equal to CD. So this over that equal to this over that, over sine of angle CAD. And AC, so you're switching over. So kind of move everything around. Okay. And we're going to do the same thing for the other triangle. let's do it for triangle ADB. So do it for this triangle. So AB over the angle D over here, so it'll be sine of angle ADB equal to, so this over this angle equal to this over this angle. So just like this over here, you kind of move things around. So you got AB over BD equal to sine of angle ADB over sine of angle DAB. Okay. Now, because the angle bisector theorem, this angle and these two angles are congruent. Okay. Okay, just by angle bisector, so you got angle CAD is congruent to angle DAB. Right? These two angles are congruent. And if the angles are congruent, then sine of the angle will be congruent. So sine of angle CAD will equal to sine of angle DAB. Okay. And also, if you look at this right over here, okay, angle ADC equal to 180 minus angle ADB. Now look at this angle over here. So angle ADC, so this angle equal to 180 minus ADB, right? So 180 minus that will give you that. Okay. And therefore, sine of angle ADC will equal to sine of angle ADB. Okay. Again, if you look at the trigonometry, the sine, okay. So if this is theta, and this would be 180 degree minus theta, and you're going to have the same sine value. Okay, right. So that's the reason for that. So these two angles have the same sine value. Okay, because they are supplementary angles. Okay, so now we can substitute all this into here. Okay. So if you combine this together, so you got sine of angle ADC over sine of angle CAD. This will equal to sine of, okay, if you look at sine of ADC is right over here, so equal to sine of angle ADB, right? And CAD is equal to sine of angle DAB. Okay? Again, this is equal to that, this is equal to that. Okay, but notice what this is equal to. Okay, this is equal to AC over, so this is equal to AC over CD. Right? And what is equal to? Well, this is equal to AB over DB. Okay, and that is the angle bisector theorem, right? AC over CD is equal to AB over DB. Okay. Okay. Let's go to next one. It says find tangent C, where C is the angle opposite of angle C, and so basically you have this. So you want to find tangent C with this as a given. Okay. Okay. So again, you have a triangle. You have a A, B, C. So this would be small a, small b, small c. And you were giving that a cube plus b cube plus c cube over a plus b plus c equal to c squared. Okay, so this is giving, and you want to find that. Okay, so first let's do some algebra. So first let's go and cross multiply to get rid of the fraction. So you get a cube plus b cube plus c cube equal to you're going to get ac squared plus bc squared plus c cube. Okay, so you can multiply, and you got both c cubes, so this will cancel out. So you end up with a cube plus b cube equal to ac squared plus bc squared. Next is, let's go ahead and do the factoring. So this is the sum of the cube. So when you factor, you're going to get a plus b, and you're going to get a squared minus ab plus b squared. On this side, you can factor out the c squared. So you get a plus b. Now again, you got a plus b, you got a plus b, so this will cancel out. Okay. And so you end up with a squared minus ab plus b squared equal to c squared. And what we're going to do next is we're going to use the law of cosine. Okay. Since we're dealing with c, so we're going to use the law of cosine for the angle c. Okay. So let's so if you use the law of cosine for angle c, so you're going to get c squared equal to a squared plus b squared minus 2ab cosine of c. Okay. And we're going to substitute this into here, c squared equal to that, so we're going to substitute this into here. Okay. So you got a squared minus ab plus b squared equal to a squared plus b squared minus 2ab cosine of c. Okay, so this will cancel out. And what we're going to do is we're going to divide by negative 2ab, divide by negative 2ab. So you get cosine of c, now this will cancel out, equal to 1/2. Okay. So once you find cosine of c equal to 1/2, so you're going to do this. Okay, so 1/2 square root of 3. Okay, so once you know the cosine of c equal to 1/2, you draw that, and now you can find tangent of c based on that picture. So tangent of c will equal to sine over cosine, so equal to square root of 3. Okay, let's go to the next one. Okay, number 43 is a point O is a center of a circle circumscribed about an isosceles triangle ABC. Okay, so let's go ahead and get an isosceles triangle. Okay, so you got A, B, C, and AC equal to 7, AB equal to 7, and BC equal to 2. You're looking for AO. Okay, okay, so let's go and draw these things down. So AO is your radius. So since the 3 sides are given, what you do is use the formula for the circumscribed circle. Okay. So the area of the ABC equal to ABC over 4R. So big R is the radius of the outside. If it's small r, it would be the radius of the inner circle. Okay. And so the area of a triangle is 1/2 base times the height. To find the height, let's go. We can use Pythagorean theorem. Okay, let's go and call this height. So it'll be 1 and 1, right? So use Pythagorean theorem. So 1 squared plus h squared equal to 7 squared, right? Use Pythagorean theorem. So 1 plus h squared equal to 49. So h squared equal to 48. So h will equal to square root of 48. And you go off to the side. So h equal to 4 square root of 3. Okay, so substituting here. Okay, so h equal to 4 square root of 3. Use your Pythagorean theorem. Okay, so it'll be 4 square root of 3, and this will equal to ABC. So A would be 2, B would be 7, C would be 7 over 4R. Okay, so let's go and move things around. So let's go and move the R out here. So move the R up there and move everything down here. Okay, so let's go and solve. So this will cancel out. This cancel with this. And since they is a square root of 3, so let's go and multiply by square root of 3 over 3. So on the top, I get 49 square root of 3. On the bottom, 2 times 4 is 8 times 3 is 24. Okay, and that's it.